In this demonstration, I'll walk you through how the Ferentin Workforce Assistant seamlessly integrates with Box by utilizing its remote MCP server. Box is a trusted enterprise content platform widely used to manage sensitive documents in regulated industries like financial services and healthcare. It efficiently organizes content into files, folders, and shared workspaces. Each folder within Box comes with specific permissions. Access to these folders is managed by Box's robust role-based and user-based controls. Over in the Box Developer Console, you can see a platform app, Ferentin AI Security Platform app configured with OAuth 2.0. The platform app details the integration, such as client authentication and the application scopes. This is all done while adhering to your existing Box security permissions and access policies. When I prompt the assistant to interact with Box, it can search for and retrieve information from permissible files or write and update content. The AI has visibility only to what is accessible to me, including folders like research and specific files. I'm logged into the Ferentin user console as an employee. If you're curious about this enterprise AI assistant and want to learn how to use the LLMs and MCP servers, there are some videos linked at the top for a quick overview. In this demonstration, I'm going to use the OpenAI GPT 5.2 model. Looking at the connector selector, I noticed that a Box server has been made available to me. Unlike other connections, it shows up as unlinked. This is because the Box MCP server requires user-scoped OAuth 2 tokens. The requirement for user-scoped tokens ensures that the system can access only the files and folders I have permission to view. This setup is different from using vaulted credentials like API keys, which can be shared across users. When I click the link, a modal dialog guides me through connecting with Box. Clicking on the button starts the authorization flow with Box and shows me the scopes used. I'll go ahead and click Grant Access to Box. Once that's completed, the dialog closes. Next, navigate to the Tools section and click on MCP Servers. Here, you can see that the Box application is now connected, and it offers various tools that we can utilize. Once Ferentin completes the authorization flow, they receive time-bound scope tokens from Box. It's important to note that any other users assigned to the MCP server using the same policy will also need to go through this authorization flow individually. With this setup, I can now interact with Box content simply using natural language. I then ask, what are the documents in the research folder? The system is designed to use available tools and make the necessary MCP tool calls to provide me with the information I need. The system responds by informing me that there are 2 files in the folder. At this point, I'm interested in more details about the content of these files, so I ask, what are the salient governance aspects mentioned in the second file? The system goes to work, summarizing the information from that specific section of the documentation in the second file. Since the Box application scopes included write, I also have the ability to write files. This means I can create folders and add content to them. I will now create a folder named Q1 FY26 and ask to write the governance details into this new folder. The system proceeds to create the folder, upload the file in a sequence of tool calls to the Box MCP server. It then provides me with a link to access it. Check out the link to see what's inside the new file we just made. You can see that it is created in the new folder named Q1 FY26. Let's dive into the governance capabilities offered by the Ferentin AI Security Platform. Here, we're at the admin console where the policies are crafted. For those AI interactions in the user console involving LLMs and the MCP tool calls, you can observe one of our main visualizations, the intent flow. In this visualization, you can see how requests move from the user, these are anonymized to protect personal information, to a specific AI client, which is the assistant in this scenario, and then onto the LLM provider like OpenAI, and then the model GPT 5.2 itself. You might notice interactions with models such as Meta and Kimi K2, which I used right before this demo. Additionally, there's the MCP server and various tools employed for this specific interaction. You can dive deeper into the actual MCP logs from here. These logs reveal how long each call took, its success status, timestamps, details about the users and AI clients involved. Now to the governance part. Let's start in the registries section where we have all the MCP servers listed. Essentially, it's like a private registry tailored for this tenant. Let's dive into the Box server. Now, in the Box MCP server, you'll notice it comes with per-user settings. You have the flexibility to select the tools from the complete list. Plus, you can enforce policies. For instance, I've configured 2 policies here, a workforce policy and a Box policy, specifying which tools and servers are associated with them. These configurations are then assessed in real time by the AI security platform, enabling the user, assistant, or the agent to effectively utilize the tools.